Hello, my dear friends. Today I'm here to deliver a lecture on a very interesting topic, which is acceleration due to gravity. Now, it's very simple, and that if there are something in a kind of series, then it becomes easy to understand what has been started and where is the end of the story, right? Like you have seen Harry Potter, there was lot of series, like 1 series to 10 series. So similarly, today I have decided, actually, I was thinking about this, and so I decided that I will not pick one unit or one topic from 10th class and then I will give lecture. Then on the next video, I will post lecture of 12th. It is not going to be beneficial for you actually. So that's why I decided that I will take some kind of series. Like we started with a last lecture of gravitation, so I decided that there should be a series of whole chapter of gravitation. So one chapter may be divided into 3 to 4 videos, like, and then one numerical part also, like 5 lectures, 5 videos of one complete unit. Then we will take next unit and we will again, then we will make 3 to 4 videos and so on. So this way we will move so that the things are obvious and clear to you. So coming back to the topic, acceleration due to gravity. So question arises in your mind, what is an acceleration? In the chapter motion, I have described acceleration in a very lucid and simple way. Okay, when you are going by a car, okay, and you start from your home and your speed is say 10 kilometer per hour, right? And up to your destination, say your office or school or college, wherever you go, you see that your speed was not constant, it was changing like 10 kilometer per hour. And then where road was, there was no vehicle on the road, that's why your speed was again, say it was increasing, and it was at 30 kilometer per hour. And then there was some crowd and your speed was again 10 kilometer per hour. So sometime there was speed was increasing, sometime it was decreasing. So at a particular time when your speed goes from 10 to 30, you can simply say that my speed has been increased. Okay, so if speed has been increased, it means there is a change in speed or velocity. If we take out direction also, we call it as velocity, because velocity is nothing but speed with direction. Okay, so when I say acceleration, what is acceleration? Change in velocity. The velocity in particular time is say 10 kilometer per hour, and after 2 minutes it is 20 kilometer per hour, right? So there is change in velocity, 20 minus 10 divided by this time, then you will get acceleration. So acceleration is nothing but rate of change of velocity. How much velocity changes gives you acceleration. Simply saying, when you say that velocity is increased, like you put your foot on the accelerator. Why this is called accelerator? Because it is used to increase the speed. So increasing speed is nothing that gives rise to acceleration. But this acceleration, which we discussed in motion chapter, was like, on a horizontal space, on a horizontal plane. It was not like on the horizon actually, and not like if we take some object and we throw it upwards. Okay, then this upward or downward motion, we don't use the word singly acceleration. No, then we use the word acceleration due to gravity. You know gravity now, because in last lecture I told you what is gravity. Gravity means the force with which earth is pulling you. Okay, the force between the earth and the object is called gravity, right? And force between any two objects is called gravitational force. In last lecture I told you especially that there is a difference between gravitational force and gravity. Now what is gravitational force? Force between any two objects, like two tables, two persons, or any two things, is called gravitational force. And the force between earth and any other object is called gravity. Gravity is also a force, right? So due to that force of gravity, if there is some acceleration, then you call it as acceleration due to gravity. Acceleration due to gravity mean acceleration is produced, but that has come due to gravity. So for a simple example, I take this marker and say I throw it from here. Just see, I throw it from here. This marker has gone down. Now, when I was just keeping it in my hand, its velocity was 0. And when I just threw it on the ground, it was a free fall. It was falling under some force, which that force created some sort of acceleration in it. And you know what that force was? That was force between earth and this marker, right? So that force is called gravity. So acceleration was produced because here velocity is 0, and when it is going downward, its velocity is increasing, right? So there is change in velocity. Whenever there is less velocity, there is higher velocity, mean there is change in velocity. What is change? Change mean higher minus lower. So there is change in velocity, sure. But why this change in velocity is there? Due to a force of gravity, which is pulling the pen downward towards the earth. So it means there is acceleration in this pen. Change in velocity means acceleration in this pen due to force of gravity, and that acceleration produced in this pen is called acceleration due to gravity. Now I think it is clear. Where we simply denote acceleration as a, but here acceleration due to gravity is denoted by small g. Always remember, there is a difference between small g, which is acceleration due to gravity, and capital G. What is capital G? In last lecture I told you it is a constant value. It is universal gravitation constant, whose value is 6.67 into 10 to the power of minus 11 Newton meter square per kilogram square. I will again and again repeat the values so that these are somewhere glued into your mind, right? So that whenever you go for numericals, you don't need to look for some table or some reference, right? So what is acceleration due to gravity? I think now you are clear about it, right? It is denoted by g. In general, its value is on the earth's surface, g equals to 9.8 meter per second square. Why meter per second square? Because acceleration has a unit meter per second square, right? Last chapter motion I told you. And this is the value 9.8, this is magnitude, okay? So small g has a value 9.8 meter per second square. So now the question arises, where this value comes from? How did we deduce this value? How this value comes? Is it a kind of calculation or some experiment? What actually is the source of this value? Why the value of g is 9.8 meter per second square? Many times you will be asked, what is the value of acceleration due to gravity on Earth's surface? You will say g equals to 9.8 meter per second square, small g. Always remember small g. Acceleration due to gravity is small g, right? So why this value is there? From where it comes? So let us derive a small derivation, small expression, very simple and very lucid. Just look at this. Let us suppose this is our earth, right? Now whenever you say earth, naturally it has a mass. So let ME, E stand is a subscript for earth and M is mass of earth, okay? Mass of earth, right? Let an object is here. This is an object and its mass is small m, right? Is there any problem? No problem. So m is the mass of object. It's very simple. When I dropped this marker, this is object m of mass m, and the earth mean our floor of the room, is Earth's surface, say this one, okay? And I've taken the mass of this whole Earth as ME, right? M is the object mass, mean the marker which we threw it on the ground, right? So now let the distance between these two is say small d, okay? So d is the distance between object and earth, object and earth, okay? What is Newton's second law? Do you know that? Have you heard about it? Okay, no problem. If you didn't hear this Newton's second law of motion, let me tell you simply. Newton's second law gives us the definition of force. However, its definition is that the rate of change of momentum is directly proportional to force. We will not go into detail because when we will do this unit force, then we will discuss it in detail. But for now, this second law, Newton's second law, gives us the definition of force, and it says that force equals to mass into acceleration. What is force? Mass into acceleration produced. Like if a body is placed here and a force is applied, you know, when we apply a force, its velocity increases or decreases? Increases. If it pushes up in the direction, then the velocity increases because here velocity is 0. We applied the force, velocity increases, say it is v. Now change in velocity is v minus 0, mean v upon, say this time was t, so v by t. So this is nothing but acceleration, rate of change of velocity. Rate means divided by time, and rate of change is v minus 0 because u is 0 here, initial velocity, right? So we see that whenever we apply a force, there is change in velocity, and due to change in velocity there is acceleration, right? In last chapter I explained each and everything in motion. You can watch my video if you have any problem. Now this F is equal to ma is also used here. How? This one means this object of mass m, this is being attracted towards earth, so it means earth is pulling it with some force. What is that force? F, right? The earth is pulling this towards its center, that is why it is going down. If I leave it, it will go down, you know that, okay? So when I am leaving this, it will go down due to the force or pull of the earth. That force is equal to F. And what is force? M into A, mass of this object, mean this pen, into acceleration. Now here acceleration is not A. I told you, when body falls like this, acceleration is nothing but acceleration due to gravity, and symbol is G. So in place of A, we use G, right? It is equation number 1. Now tell me, is it okay or not? I think it's okay, right? So now, if we apply Newton universal law of gravitation in two bodies, which two bodies? One is object, this marker, and other body is earth. So according to Newton's universal law of gravitation, force between this body and earth will be given by capital G m1 m2, it means mass of first body into mass of second body. Mass of first body m, mass of second body me, earth is the second body, divided by the distance between them, square, d square, right? It is equation number 2. Is that okay for you? Right. Now just look, it's very easy, it's not difficult. Now this is force, this is force. If these sides are equal, right hand side will also be equal. So mg equals to g me m upon d square. So m can got cancelled by algebra, So G equals to G me upon D square, right? Now we take a special case. What special case? We have received the formula of G, but still it is incomplete. Why? We told you that this body is d distance apart from the earth. Let us suppose it is not d distance apart. It is this body is at this point. Mean now the picture becomes this one. Okay. So anybody, this is me, this is M. Can you tell me now what will be the value of d? D is what? Distance between. Somebody will say, sir, d becomes 0. No, 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 no. What is d? D is the distance between object and the earth. What is now the distance? This one. What is this one? What is this one? This is radius of earth. Earth has some radius, right? So when object is on surface of earth, then G can be written as G me upon D. In place of D, we will put RE, radius of earth square. So this is the formula which we use. And this question may be asked like this. Derive a relation between small g and capital G. Then also you will do this exercise. Otherwise, they will ask you, what is acceleration due to gravity? Find its value on the surface of earth. So just look at this. Small g equals to capital G into mass of earth into radius of earth. If I put the value of G, if I put the value of me, if I put the value of Re, you know what I'm going to get? Small g. Let us check what is the value that comes. 6.67 10 to the power minus 11. Mass of earth is 6 into 10 to the power 24 kilogram, right? Divided by Re. Re is 6.4 into 10 to the power 6 meter square. If you solve this value, G nearly comes out to be 9.8 meter per second square. This is the value which we had to find out, and that we have found out now. Simply we put the value of G. What is G? Universal gravitation constant. In last lecture I told you its value is fixed. What is me? Mass of earth. 6 into 10 to the power 24 kilogram. Mass of earth is fixed constant. Radius of earth constant. 6.4 10 to the power 6 meter. And if we solve all the things, we will get 9.8 meter per second square. So always remember the value of G is 9.8 meter per second square on the surface of earth. Now, astonishing thing. If we go on moon, if you go on moon, you know, this G becomes G by 6 on moon. In Indian system of education and Indian culture, we were told that moon is our mama, mean brother of our mother, right? So if we go there at the moon, our acceleration due to gravity will be 1/6 as that of earth. Suppose on earth it is 9.8. So on moon it will be 9.8 divided by 6, very less. You know, if the acceleration due to gravity is less, do you feel that you can stand like this? No. If there is no gravity, you will float like this, right? As you see the astronauts, because they are in gravity-less atmosphere. Okay? It is very difficult like Sunita Williams. She is an astronaut and she is still there, but we also pray to God that she will come back safely along with her crew. So NASA is very good, NASA is not a simple entity. They will surely bring back our astronauts and their crew also. So when we were discussing small g, we saw that on moon it is g by 6. Does it changes something in our life? Yes, weight. Now you will say, what is weight? Weight is W equals to mg. We will discuss in next lecture what is weight actually. But before that, W equals to mg, mass into acceleration due to gravity. I told you, when you go to moon, your g will be g by 6, right? So it means if you are using a weighing machine on the earth and your weight it is showing as 60 kg, okay, and now you go to moon and bring it and take it with you, what, weighing machine, and weigh and just measure your weight on the moon, on the surface of moon by placing the weighing machine. You will be astonished to see that the needle goes only up to 10 kg. So it means now your weight on the moon is 10 kg, but your weight on earth is 60 kg. Does it make some difference? Is it possible that your weight is 10 kg? So weight is a feeling of force with which something is attracted towards the center of earth. But one thing remains constant: your muscles, your powers, your body, your clothes. So it means there is something which will remain constant, and that constant thing is called mass. In next lecture, we will discuss this mass and weight, and we will prove that on the surface of moon, the weight is 1/6 of the weight on that of earth, right? It is very interesting if you just do the practice part. This is a mathematical thing. Do practice part, only you can, then you can become a scientist or whatever you like. Whatever you learn from your lessons, whatever you learn from your teachers, always try to understand that. Then you just take a rough notebook and try to write it down by understanding the concept, understanding the diagrams, so that you do not need to cram the things, right? Because cramming leads to devastation in the end. Okay, so thank you very much for patience hearing, and I will request you once again to please subscribe to my channel if you are new, and press the bell button for sure, so that everything is clear in your mind that new lecture is being uploaded and we have to see that, we have to watch that. Okay, thank you very much.